Okay, so as you try to now hopefully see the big picture, okay? So there's some of you are fond of always statements, okay? So if you have a convex mirror, okay? Convex mirror, which you can model
What the heck?
as this sphere.
Why do you gotta throw that into it?
Huh?
I said, why do you gotta throw that into it?
Oh, no, but seriously,
Why do you
look at
gotta
it,
do that?
okay? So no matter where I put this thing, does the image ever flip over?
No.
Okay? So it's always upright, right?
Right.
And you all look small.
Yeah.
Right? Right? So, is this image, do you think, a real image or a virtual image? Virtual. So if all I saw was this, I would think, wow, my class is short. I'm teaching second grade.
Yo.
And they're in this weird kind of dome. And they're inside this ball. Okay? So, and this is going to be important. This is going to be important today. Okay? You have to remember that your eye wants to recreate and trace back and put an image somewhere, like where that originated. So, on a convex mirror, what is the sign of the focal length
Negative.
always on a convex mirror?
Negative.
Why?
I made like
Because it like separates.
Okay? The light hits and it bounces off, right?
First time.
Now, when you are drawing a mirror ray diagram,
Pizza.
what's the one of the first ones you draw every time?
Good point.
The one with the pizza, right?
Pizza.
So, whatever this image is, right?
First thing.
Handle, whatever.
My bad.
The first one you draw, as Nathan calls it, is the pizza slice. And the pizza slice is symmetrical. So if this is like 2 squares up, this is going to be 2 squares down.
Good job, man.
It's going to come in, it's going to hit the middle, it's going to bounce back. So here's what's important about this. And then you extend that line back out like this. Okay? So what that tells you, and again, cannot emphasize this enough. So with a mirror, either that image is here and it's inverted, or it's somewhere out there and it's upright. Those are your only 2 options. That's it. Only 2. So this at least narrows it down. It's got to be here or it's got to be up there. Second one, draw that parallel with that primary axis. Now, there's a focal point on the other side. And this is what's hard to visualize, is that you have a focal point on the other side of this that these are trying to converge to, but yet they hit and they bounce back, but yet they kind of want to go to the focal point, which sounds really weird. But it works mathematically and it works conceptually. So when this hits, this line is going to try and go through that focal point that's on the other side. So that's going to bounce off, boom, like this. So right away, as soon as those 2 rays cross, I know pretty good idea that's where the image is going to be. So notice on this, I have an upright image that is inverted or upright. Upright. Real virtual. Virtual. So this is why, like, even it's kind of weird when I sit here and I lecture, right? And I'm looking at this ball, I'm seeing myself, but I look small, but I look upright, okay? But I'm not actually back behind there, all right? Got that one. So, convex mirrors. These are your always statements. The focal length is always negative. The image is always virtual. It's always upright, and it's always small. Magnification will always be less than 1. Okay? Always. Now, when you have a concave mirror, those have different options. But again, what's the first line you draw?
Pizza.
The pizza line. So if the focal length is out here, and you're inside of that, you draw the pizza line. That's what I'm going to call it from now on out, by the way. Pizza line. Okay?
I better be sided.
No one's psyching.
So again, what are your only two options? Where can it appear?
The right or the left?
Or to the
Bottom left, upper right. Only two places it can be. That's it. That's it. That's it. So you have a focal length. So the line comes in here, and it's going to hit this. Where's it going to try and go? It's going to try and go back through that focal point here. Okay? And then you can extend that line up like this. So if the object is inside the focal length, here's what I want you to see. These two lines here, never going to meet. Can't form the image on that side. But I can make one on the other side. So if you were inside the focal length, what do you get in terms of an image? An upright image that is
Magnified, bigger.
magnified big. So if you don't believe me, here, take this. Whoa. Those are in there. Hold this really close to you. Okay? Right? Can y'all see this? Kind of disturbing. Right? So I am very much, I got to get really close because I have to be inside the focal length. Now, if I hold this thing farther out, what happens?
You're upside down.
I'm upside down, but then I'm outside the focal length. Now, if I go like in between, that gets weird. Okay? So, because in between it basically becomes undefined. So you're either going to be inside and you're upright and close, or you're outside of it and you're inverted. Okay? Yes?
So a difference between those and those, the line parallel to the line parallel over the object. On the other one, it goes, it's the opposite focal point, but on concave, it's the same focal point.
Okay? I say again. Okay.
Usually there's three rays. It's right here.
Now, this one. I'm going to put the object out here, and I'm going to put the focal point here. First line you draw, pizza line. Doink. 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 Right? Draw it parallel with it. Where does it want to go?
Back.
No, it wants to go through that focal point.
Yeah.
Okay, this is a concave mirror. It wants to go through that focal point.
Yes.
So, again, I'm either out there in the nether world or I'm in here. Where do those lines cross?
Bottom left.
Here.
Bottom left. So what's that going to get me? An inverted image.
That's real.
That's real. Because look,
Oh,
if I try and take this line back up like this,
never converted.
it's never going to meet. So if I'm inside the focal length, I can't make an image on the other side because those lines never cross. Though that gives you the most fits right there. If you can have straight concave mirrors in two scenarios, cool deal. Now, concave lens. Concave lens. What's going to happen? Here's the light. It's going to come in. What's it going to do, Ryan? It's going to diverge. So what's the sign on the focal length on a concave lens?
Negative people spread people out.
Press me west. A negative situation, right? People are going to go away from you. Well, what? So that line goes out like that. But then part of that is going to come back, and we're going to meet. Okay? And then part of this is going to go through here like this. So, what are you going to get?
Image. Tiny image.
A tiny image that is
virtual.
virtual. Because the light is going in the opposite direction. Oh, you have to remember about that. So that's the only thing you can get. What?
Can you get a real image of it?
No. Because that light is being diverged out.
But if you put a paper on the other side, you wouldn't have the virtual image.
No. So if you like put your hand over there, nothing would happen. You don't need the mirrors right there. Okay, the other one, concave lens. That's the easy money.
I love that one.
Okay. Boom, comes in, crosses through the middle, goes through the focal. Or that, let's keep that out.
It's way not gonna be.
Goes through that focal length. Boom.
Where are you going?
Goes through that focal length, which I completely just screwed that up. Let me start over. That was
It's still beautiful.
No, it wasn't. That was horrible. It is just isn't. I'm so sorry. It just is. You have the loudest arena in the country. Like that matters? Yeah. Oh my god, our arena is so loud.
Boom.
Like, we know you don't like Ryan,
Down.
how are you more supposed to do this?
boom.
You really like it.
So, if you have a convex lens, what are you going to get? Inverted or upright?
Inverted.
Inverted. Guess what your eyeball is?
That's the down.
Your eyeball is a convex lens. So how are you seeing me right now?
Upright, but it's really
You're
upside
seeing
down.
me upside down.
My brain's locked in, so you know,
Sorry.
you're seeing it.
Now, so if you're, but right now you all look a little bit blurry. So what's the purpose of glasses?
Oh, to fix it.
Yeah, that we adjust the focal length so that it becomes an image on the back of my eyeball.
Thank you.
Okay, quick summary. Got it? Good, Brand? Okay, Mara, stop you on the camera. Let's go to the back.